Section 1.4 is on angle measure. But before we start talking about angles, let's talk about a couple other terms first. A ray is a part of a line. A ray has one endpoint and then extends infinitely in the other direction. So looking at this diagram right here, I have point A, point B, and point C, and they all lie. They're collinear here. But notice there's an arrow on this side, but not on this side. So this actually represents several rays. So I can talk about ray AC. So I can call this ray AC, which would have an endpoint of A and continue in this direction through point C. Okay. I could also refer to this as ray AB, because that would do the same thing. I could talk about ray BC, and that would be starting right here at point B and continuing this direction towards the arrow, but would not include this segment back here, segment AB. Okay. Now, when you're naming a ray, the first letter has to be the end point. I know when we said we were naming a line or a line segment, the order didn't matter, but for a ray, it does. So I can refer to ray AB or ray AC, but not ray BA, because that would be going in the other direction and the arrow doesn't go that way. Nor can I call it ray CA. Now, opposite rays share a common endpoint and are collinear. So basically, they're two rays that go in opposite directions and have the same endpoint. So ray KJ, which would represent just this part of it starting at K and moving left through J and continuing forever, and ray KL, again starting at point K and continuing to the right through point L forever, those are opposite rays. They're collinear, they make a straight line, and they share the common endpoint K. Now the definition of an angle is two non-collinear rays that share a common endpoint. So they're not opposite rays, but they do share a common endpoint because they're not collinear. So here we have an angle, and its two sides are rays AB and AC. Its vertex is point A, and that's going to be always the letter in the middle. And I can name this as angle A, that's the symbol for an angle, and you name the vertex. Or I could name it angle BAC, so starting with B, going to A, and then out through C. Or I could name this angle CAB, starting at C, going to A, and then out through B. So for an angle, the order doesn't matter, but you'll notice that the vertex A has to be in the middle. I cannot talk about angle BCA because I don't have that drawn. This would be angle BAC or angle CAB. And sometimes you'll see a little number kind of in the squat part here of the angle. And so that means that I can also refer to this as angle 4. Sometimes in a diagram, if there's a lot of things going on, it's just easier to name an angle with a number. Okay, so here's an important note. You can only use a single letter, and that is the vertex, to name the angle if there's only one angle that has that as its vertex. Okay, so looking at this diagram here, you'll see I see three angles. I see the small one on top, the small one on the bottom, and then the big one. So there's angle BAC, angle CAD, and angle BAD. So to call this angle A is ambiguous. I don't know which of the three angles you're talking about. If it's a simple diagram like this where there's only one angle, perfectly okay to call this angle A. But if you talk about angle A in reference to this diagram, I don't know which of the three angles you're talking about. So in that case, you'd have to use three letters. An angle divides the plane into three parts. There is the angle itself, and so in this diagram that would be angle PRS. There's the interior of the angle, and that would be this part right in here. And you'll notice that point Q lies in the interior of angle PRS. And then there's also the exterior of the angle. That's all of this area out here, and point T lies in the exterior of angle PRS. Angles are measured in degrees. Actually, you can also measure angles in radians, but we won't talk about that until we get to Algebra 2. Okay, but for now we're going to use degrees, and a degree is 1/360th of a circle. And maybe you already knew that a circle has 360 degrees in it. So a degree is just one small little fraction of that circle. And then the way we denote that in geometry is we put a lowercase printed m outside the angle and then name the angle. So this says the measure of angle DEF is equal to 50. And for some reason we don't usually use the little degree symbol. I'll use it in my notes on the next page or two, but for the most of the time we just kind of know that that means degrees. So the measure of angle DEF equals 50. There's a few other definitions you might already know. A right angle measures 90 degrees, and we designate it as a right angle by putting that little box in there. I don't know it's a right angle unless it has that little box there. Okay, an acute angle measures between 0 degrees and 90 degrees. An obtuse angle measures between 90 degrees and 180 degrees. And occasionally you'll see people refer to something called a straight angle, which is basically just a straight line, and it measures 180 degrees. Okay, so from any point here going all the way over to here is 180 degrees. Okay, so here's a diagram with a couple angles in it and a few things we need to do with it. So number 1 says name all of the angles that have B as their vertex. So I'm seeing angle ABD, which is a right angle. Angle DBE. Angle EBC. And actually DBE, angle DBE is the same as angle 2. Angle EBC is the same as angle 1. Okay. I also have angle DBC. And I think I have one more, angle ABE. Okay, so I believe there are 5 angles in that diagram. Okay, give another name for angle EBD. Angle EBD. Okay, I can refer to that as angle 2, which I kind of already did over here. I can also refer to it as angle DBE. So I can go from E to B through D, or DBE. The main thing is B is the vertex, and that has to be in the middle of the 3 letters. Number 3, name a point that's in the interior of angle EBA. So angle EBA is this obtuse angle right here, and a point that's on the interior of that would be point D. Number 4, name the sides of angle 1. Recall that the sides of an angle are rays. So that would be ray BE and ray BC. And I write it like this: ray BE with the line going in one direction, and ray BC, the line going in one direction. Notice I cannot talk about ray BEB or ray CB because that would be going in the wrong direction. And now classify each one of these triangles, or each one of these angles. Angle ABE, because that is greater than a 90-degree angle, that one's going to be obtuse. Angle DBE, because that's less than 90, that's going to be acute. And angle DBA is a right angle, and I know that because it's got the little box right there. Okay, just like we had the definition of congruent segments, we also have the definition of congruent angles. And this says 2 angles are congruent if and only if they have the same measure. Okay, so in this case I have angle BAC, which is congruent to angle EAD. And notice I have these little arcs kind of in the angles here. That means that those are congruent to each other. So if the measure of angle BAC is equal to the measure of angle EAD, so in other words, if this one's 30 degrees and this one's 30 degrees, then I can say that the 2 angles are congruent. Notice the notation here. If I have the little m out front for the measure, then I use an equal sign. If there's no little m, just the angle sign, then I use congruent. Okay, and the converse of that is also true. If the 2 angles are congruent to each other, then their measures are equal. Okay, remember the angle itself refers to that angle. The little m means the measure of that angle, so something like 30 degrees or 50 degrees. An angle bisector is a ray that divides an angle into two congruent angles. Okay, so if ray AC bisects angle BAD, then angle BAC is congruent to angle CAD. Let's go ahead and mark this. So if this ray AC is an angle bisector, if it's bisecting big angle BAD, then angle BAC is congruent to angle CAD. And that's how we would mark it. You'll also notice that it's kind of like the betweenness of points that we had, that the measure of angle BAC plus the measure of angle CAD is equal to the measure of angle BAD. So the two little angles add up to the big angle. Oops, I think I lost my diagram. Hold on a second here. This is the diagram I want. Sorry about that. Let me go ahead and move this back up there. Okay. Sorry about that. Okay, there's my diagram. Let me bring that down a little bit. Okay, there's my diagram. Sorry. Okay, this problem says that if the measure of angle JKN is equal to 8x minus 13, and the measure of angle NKL is equal to 6x plus 11, find the measure of JKN. Oops, I just made a mistake. I skipped a very important step, which is actually reading this stuff over here. And this gives me a lot of information about the picture, because just reading the problem here, I can't figure out what's going on. So, if KJ and KM are opposite rays, KJ and KM are opposite rays, then I know that this is a straight line, and that's going to measure 180 degrees. Any angles that make up that line are going to measure 180 degrees. It also says that ray KN bisects angle JKL. So I think I need to mark that. Ray KN bisects angle JKL, so that means that this angle is congruent to this angle. So from this, I know that angle JKN is congruent to angle NKL, because KN is an angle bisector and cuts that angle in half. Okay, now I can go back to my problem. So here I have an algebraic expression for JKN, which is helpful, and here I have an algebraic expression for NKL. Well, since KN cuts that big angle into two congruent angles, I know that the measure of angle JKN is equal to the measure of angle NKL, because those two angles are the same size. So now I can just plug in the algebraic expressions here. So 8x minus 13 is equal to 6x plus 11. Solving that for x, I have 2x equals 24, or x equals 12. And as always in geometry, don't box what x equals. Go back and read the problem. It says find the measure of angle JKN. So the measure of angle JKN was defined as 8x minus 13, plugging in 12 for that gives me, what does that give me? 96 minus 13, or the measure of that angle is 83 degrees. Okay? For number 2 here, you know what, I'm going to take my diagram, I'm going to take this diagram and move it back down below there for the next problem. Let's bring it down here. Okay, there we go. All right, given that same information about the diagram, okay, that we have opposite rays and an angle bisector, if the measure of angle JKL is 9y plus 15 and the measure of angle JKN is 5y plus 2, find the measure of angle JKL. So let's go ahead and I'm going to mark those a little bit. So I'm looking at angle JKL. So that's this whole big angle right here is JKL. And then it says JKN, which is just this angle right here. Oh, actually I already have it marked. JKN is that one right there, is that right there. Then find the measure of angle JKL. Okay, so I know that JKN and NKL are congruent to each other. So what that means is, well, let's go ahead and write this. So angle JKL, that's the big one, is equal to the two smaller angles. The measure of angle JKN plus the measure of angle NKL. So big angle that I marked in blue is equal to JKN, the smaller angle that I've marked in both pink and green, and angle NKL, which is marked in just pink. Okay, but I know because KN is a bisector that these two smaller angles are equal to each other. So I can actually substitute, which one do I know? I know about JKN. I can actually substitute JKN into here for NKL. Okay, let me go over that again. Since the two angles that are marked in pink are equal to each other, okay, I can substitute one in for the other. And now I have enough information, I think, to go ahead and solve this algebraically. So 9y plus 15 equals, and actually there's a couple ways I could do this. Since there's two of those, I could just say 2 times 5y plus 2, because notice they're both the same thing. 9y plus 15 equals 10y plus 4. Or solving this for y, let's subtract 9y, and then let's subtract 4. So y is equal to 11, okay, and again, that's not my final answer. It says find the measure of angle JKL, and JKL is 9 times y plus 15, or 99 plus 15, or 114. So in this lesson, we were introduced to angles and rays. And again, a lot more definitions and notation regarding angles. Make sure you memorize that. And just a couple hints, make sure that you draw a picture if necessary, copy the diagram, label it if you need to. And I actually find that using different colors can be very helpful.